Hi again, everyone. It's truly a privilege to be here today, especially as this marks my final time as co-chair for KubeCon, Cloud Native Con. It's been an incredible journey, and I couldn't think of a better way to wrap it up than here in London with all of you. So let's talk a little bit about observability. For years, we relied on the three pillars of observability: logs, traces, and metrics. But here's the thing: we don't have a metrics problem or tracing problem, we have a systems problem. And yet many of us still treat these as separate entities. We have one browser tabs for logs, one for metrics, and a third one for tracing. And we're relying on humans to correlate signals together. It's inefficient, it's error-prone, and it's not how modern observability should work. So many teams settle for a good enough approach, and observability is often an afterthought, but it shouldn't be. And this fragmentation leads to multiple challenges. We have many different systems rely on complex query languages, making it difficult to unify insights. Vendor login restricts flexibility and causes barriers to switching tools. Metadata inconsistency across platforms results in unreliable correlations. And due to high complexity, many teams avoid instrumentation altogether, leading to gaps in visibility. And with no unified insights, troubleshooting remains slow and inefficient, forcing engineers to manually piece together information across disparate systems. So a shift is happening. It's a shift toward correlation. It's a shift toward standardization. It's a shift toward OpenTelemetry. This is where the community really comes together. OpenTelemetry, or OTel for short, is a CNCF project and is now the second largest project within the CNCF by contributor count. It has become the de facto standard for distributed tracing and now extends to logs and metrics as well. OpenTelemetry eliminates proprietary agents, reduces metadata fragmentation, and enables cross-signal correlation. And it brings four key advantages. First, instrument once, write your instrumentation once, and it works across any backend without breaking changes. Second, it separates telemetry generation from analysis. OpenTelemetry then ensures that telemetry is produced independently from the tools that are analyzing it. And this allows teams to switch platforms without re-instrumenting, while vendors focus on analytics instead of this proprietary instrumentation. And third, it makes software observable by default. Open source libraries can now ship with native instrumentation with no extra effort required from your end, which is really, really nice. And finally, it improves how we use telemetry. By linking signals together, OpenTelemetry drastically reduces cognitive load, making troubleshooting far more efficient. And this is really the observability shift we've been waiting for. But let's take this a step further. Observability isn't just about better data, it's also about making that data accessible and actionable. And that's really where platform engineering comes in. By applying platform engineering principles, we can transform observability from an afterthought into a seamless, scalable, and developer-friendly experience. Developers shouldn't struggle with complex configuration. Observability should be built in with OpenTelemetry, enabling auto-instrumentation for effortless telemetry collection. And OpenTelemetry provides vendor-neutral APIs to ensure consistent telemetry collection. Its semantic conventions standardizes naming across traces, metrics, and logs, enabling automatic correlation and reducing inconsistencies between services. And rather than leaving teams to figure out observability on their own, platform engineers should define best practices, workflows that make it easy to implement observability correctly. And different services, of course, have different observability needs. And the OpenTelemetry collector, its architecture supports flexible pipelines, allowing teams to customize their telemetry and how they should use it. And of course, observability should be treated as a product with support, documentation, and continuous improvement. And a strong observability platform ensures effortlessly telemetry collection, cross-signal correlation, and integration into existing workflows. So by embedding observability into developer workflows, we remove friction, reduce toil, and unlock real value. But let's focus a little bit on the automatic instrumentation part and the self-service part. Platform engineering teams can give developers a strong observability foundation without them touching a single line of code. This is really where the OpenTelemetry operator comes in. It enables automatic instrumentation for applications in Go, Node.js, .NET Core, Java, and Ruby. But observability doesn't stop at instrumentation. We, of course, also need monitoring as code. This is where Perseus, another CNCF project, comes in, a sandbox project in this case. And Perseus provide an open dashboard specification and really eliminating vendor login in this case. So now we can use Perseus as that standard. It enables dashboard as code, so teams can define dashboards in YAML, as we all love, I guess, apply GitOps, and version control them like any other application code. And this approach makes observability an integral part of the development lifecycle. So now let's see it all in action. I built two small applications, a Spring Boot application using MySQL and a Go application using PostgreSQL. We'll deploy these services and demonstrate auto-instrumentation using the OpenTelemetry operator, and telemetry will be sent to Prometheus and for metrics and Jaeger for tracing. And finally, we'll use Perseus to manage dashboards as code, and all of this is running on a local Kine cluster. So if we can switch to the demo. So what you see here is get pods, you all know that command, I guess. So this is what we have in the cluster. We have the OpenTelemetry operator running. It manages a few OpenTelemetry collectors. And then we have the Perseus operator running, which manages a Perseus server, as you see here. We have Jaeger for tracing. We have Prometheus for monitoring. We have the two databases I mentioned before, like MySQL and Postgres. And then we have the two to-do applications. It's very simple applications written in Go and one written in Java. And the OpenTelemetry operator provides a custom resource for OpenTelemetry collectors. And in this case, I have two OpenTelemetry collectors running, one deployed as a daemon set for node-level telemetry, and another one deployed as a stateful set, in this case, for more cluster-wide telemetry. And if you want to learn more about this, I wrote a blog post on the -0 blog, and you can read more about how to configure that. But let's have a look at the collector quickly. If you're not familiar, it defines like different pipelines for the different signals. So in this case, metrics. We will receive metrics using the OTLP protocol, get some kubelet stats, and then we will forward that to Prometheus. And for tracing, also OTLP, and then we'll forward that data to Jaeger, or these traces to Jaeger. We do some processing in between, and this is how we are collecting the data. Then I want to show you the application now. It's a Spring Boot application. There we have it. And what you should note here is there's no custom instrumentation in this file at all, and not much else. It's just a Spring Boot application. It's fairly simple. And again, this is the REST controller handling everything. No custom instrumentation or anything like that. It's simple Spring Boot function calls for get, post, update, delete. And we want to instrument this application without touching the code at all. And for that, the OpenTelemetry operator now has this instrumentation resource. It's a custom, it's a CRD called an instrumentation. You give it a name. In this case, I just gave it the name instrumentation. I put it in the namespace OpenTelemetry. And then we define where we want to send our data. So in this case, it will be to the collector I just showed you before. We can do like configuration of the sampler. We can add, like we want UIDs for our Kubernetes resources, and we can configure for the different languages how we want the operator to inject the different auto-instrumentation. So we apply that to the cluster, and nothing really happens. As you can see here, it's you need to opt in. So we will edit the deployment for our to-do Go application. We need to add an annotation to the pod spec. And we do that right here. As you can note, I cheated a little bit. I put in a line and another annotation, which is necessary for the Go auto-instrumentation. It utilizes eBPF underneath, and you need to specify where the binary is. In this case, it's called to-do at the root. And then we tell the operator to inject Go. We will do the same thing for our Java application, but without that additional annotation, as you can see here. So we will add the annotation, hopefully. There we go. And then instead of injecting Go, we are now injecting Java into the, we want to tell the operator that this is Java, and we point to our instrumentation resource that I showed you before. It's the namespace and the name of the actual resource. And now we can see a few things is happening to our applications. So let's just have a deeper dive into what it actually did for our Java application. It added a few environment variables, as you can see, on what is the service name. But the thing you need to note here is the Java tool option. It adds this additional Java agent that is really handling all the instrumentation for you. And that comes in through an init container, as you can see up here at the top. And that is really what is handling all the auto instrumentation. And for the Go one, as you can note that there's a sidecar here, which is the eBPF sidecar. I also wrote a blog post about this a month ago. You can read more about that on the -0 blog as well if you're interested. So let's try and put in some requests, see it all in action. So I will just port forward this into my local machine, and I will do a few requests to the actual service. And it's a to-do application, so I guess we need to buy some hotel swag, so maybe a t-shirt. So we'll just put in a few to-dos there. We can, of course, see that everything was created correctly in the database. So now we have a few calls for our Java service, and we'll do the same thing for our Go application. So remember to go by to the Cloud Native Corner store or something like that and buy a hotel t-shirts or whatever. And it's the same thing. So we're moving into Jaeger now for our tracing, just to see that now we actually get data out of the box without touching the code. You can see we'll find the traces, and now we have traces for the Go application. And we'll have a deeper dive into the Java one. Yeah, here we go. Because the Java application is a little bit more instrumented, or the libraries are a little bit better instrumented. And you can see we have 6 spans. We click on a span, and this is the information we get out of the box without touching the code. We can see durations, we can see the different calls going on. We can actually see what the application is doing towards the database. And all of these follow the semantic conventions, of course, by OpenTelemetry. So that's quite nice that we can get all of this out of the box without touching the code. Cool. Then the last thing I want to show you is Perseus. Perseus comes with this data source. So we, of course, need to define where is our data. So for that, there's this data source, Perseus data source type. And in this case, we are really just pointing to the local Prometheus cluster, or not cluster, but the Prometheus server that we are running in our cluster. And that's where it can query its data. We apply that into the cluster. I should say that Perseus is still in alpha, so don't probably not use it in production, but I just want to show you where we are, and there's a lot of people that are like forming around this project. So the database, or the data source was created. It's a Prometheus data source. Everything seems to work pretty well. We will clear again. The last thing I want to show you is of course, a dashboard. And this is the resource. It's called a Perseus dashboard. Sorry for all the scrolling, but it's a pretty big file. But you define, like again, the name. You put in the namespace you want to put this in. And then you define your different panels and the time series charts, the queries you want to do. And then you can lay it all out in a grid. Again, there's a lot of scrolling. The grid comes here. And I'm really bad at scrolling, apparently. So we lay out the different panels and we define the grid, and that's really how you build a dashboard in Perseus. Apply that to the cluster, and you will see a dashboard in the Perseus server in a second. We'll go and refresh, and then we have metrics, which is awesome. And a lot of vendors are now also conforming on this as a standard for how they're doing their dashboarding. So if we can go back to the slides. So what did we just see? We used OpenTelemetry operator to instrument Java and Go applications without modifying the code. This allowed us to capture traces and metrics. We saw how auto-instrumentation makes observability frictionless, enabling teams to gain insights into their applications without any additional effort. We also deployed Perseus dashboards as code, showcasing how observability can be managed by GitOps, or using GitOps principles. And by treating dashboards and monitoring configurations as code, we ensure consistency, version control, and easy integration with existing workflows. So this demo highlighted that observability doesn't have to be complex or require massive engineering effort. It can be built into the platform, making it accessible for every team. So observability is evolving, and it is evolving quite fast these days. OpenTelemetry is standardizing telemetry collection, so the days of fragmented data are numbered. There we go. Perseus is standardizing dashboarding, and by applying platform engineering principles, we can transform observability from an afterthought into a seamless, scalable, and developer-friendly experience. And again, observability is a systems problem, not a tracing, logging, or metrics problem. And when we connect signals together, we empower developers to solve problems faster. Here's a few resources before we wrap up. I really encourage you to go and visit the OpenTelemetry Observatory booth at S400. I really enjoyed the OpenTelemetry course and the certification. It's a really good way to learn about these technologies, and of course, there's some great books on this as well. And thank you all for your time. If you want to check this out, you can scan this, or you can go into the GitHub repo and try it out yourself. It should be fairly easy to get started. And if you want to continue the conversation, I'll be at the Dash Zero booth right after this, so come and say hello, and then, yeah, enjoy the rest of KubeCon, Cloud Native Con.